Come in so that I'll make a short intro and then everyone will be manipulating, but it's better if you can enter. Yeah. And one of the point actually is that talking about Brownian motion is good, but there is also an important feature is to see it. And so somehow when we were preparing the lecture of this week, today actually would be essentially trying to see Brownian motion. So if by the end of the afternoon or by the end of midnight, you have seen Brownian motion, it's good. So for this, to see Brownian motion, you need, what do you need to see a Brownian motion? You need colloid, right? So we brought colloid. I brought colloid from Strasbourg, and also Soban also has, prepared also some colloid. So we have colloid. So we need to prepare a sample. And what else do we need to see Brownian motion? Microscope, right? So we took some microscopes. Now the deal was that how many are you? I don't know, but we're going to count in a second. The idea is that each of you has a microscope, which is, kind of challenging. So we thought about one option. And then the third thing that we need to quantify Brownian motion is to have something to record. And you have an amazing instrument to record, which is your cell phone. Yes. When I was a student, I didn't have a cell phone because simply there was no cell phone, right? But you have the apparatus to measure. Basically, you have a way to acquire Brownian motion with your own cell phone. So we brainstormed and we said, what about having you trying to record Brownian motion with your cell phone, a microscope, and a sample? So the game today is going to for you to prepare a microscope. I'll show you which microscope you're talking about. Prepare a sample so that basically you have a sample with colloid. And the third one is to record Brownian motion. And the fourth one is going to be to quantify the Brownian motion. So basically, at the end of the day, my hope is that you remember at the end of of this morning, I was showing you a particle moving up and down. My hope is that by the end of today, I hope, you will have your own movie of moving particle, and eventually that you will quantify the motion. So far, so good? Okay. So in terms of microscopes, anyone has heard already about foldscope or not? Yeah. Yes? Manu Prakash. So one idea was somehow to say, what about having a microscope in your hand? And so I took from France, she's coming from the United States originally. Believe it or not, but this is a microscope. So it's called a foldscope because it is made out of paper. So it's extremely clever. If you go through the detail, it's really, really nice. And I'll show you the pieces, and then we'll separate into groups so that you can get started trying to acquire. And again, the idea is to have a microscope, colloids, and your camera. So I'll show you the first steps. Here, you're familiar with origami? You take a paper and you fold, so it's folding, so you fold paper. And the way they designed it is essentially you unfold this, you put the sample right here, you close so that basically there is a magnet and the sample will be held tight. And on the other side, there is a kind of microscope where you can put an objective. And then you select the magnification. There is another magnet. It goes exactly on the right spot. And then you look at it with the light and you move like this and you can focus. The idea is that you will take your cell phone, put the sample of colloid, put your camera right behind it, and record Brownian motion the same way there was Brownian motion this morning. We have 2 hours in front of us, or 2.5 hours, or 3 hours. We have time, right? So it's basically no rush. So that's the game, basically, trying to acquire the particle motion in this afternoon. So this is a foldscope that is already mounted. Now, what I took from, what I ordered and brought with me was a foldscope that need to be mounted. So basically, it looks like this. It's an assembly kit, out of which you will have to mount your microscope. I will give you the objective, and basically you will have the time. You can go online, basically, to see how to mount it. I think you will need about half an hour to mount it the right way, and then we'll prepare the sample little by little, okay? So we have 20 foldscope like this. We have 20 objective also, and Soban has prepared also this type of, and I'll let you introduce because I haven't used them yet.
This is microscope. Here the magnification you can vary from 100 to 250x. Here is you can focus. You can this is the sample. You can sample holder. You put your sample over here, and here this is the one you can put over here, and put your mobile camera over here, and then by varying, by focusing, with playing this one, you can see the Brownian motion inside the water.
So that's very easy if we speak about it. Now, the real thing is going to be, doing the experiment. I don't know how many you are. 50, 60?
I think it's around 40 maybe.
40? Okay, and we have how many rooms do we have?
We have 2 rooms.
We have 2 rooms.
2.5 rooms. Another room also we can open.
2.5 rooms. Okay. So can I make the following proposition? Can you team up into pairs of, basically 2 by 2?
Maybe how many photoscopes do we have?
20.
20. So we can start with a pair of people.
Pair of people. That's what. Yes.
If less, then we can add.
And then, because if we have full scope plus this one, we'll end up with 27.
Yeah.
So I think if you work as pair, it should work. So try to find the person you would like to work with.
Yeah. Then we will divide into 2 rooms. 50% will go in the other room.
Is it okay like this? So you I think it's better if you select your spontaneously.
So maybe what is next? Do we want to distribute?
What I propose is that everyone goes into, let's say, if you are 50, there's going to be 10 here. Yeah, 10, 10, 5.
Yes.
10, 10, 5.
Yeah.
So 10 people will stay here, 10 people will go there. Sorry, yes. 20, and 10.
Yes. So maybe 15, 20 people, if we can go to other room, then we will know how many are left, then we will put them in the other room. Okay? So that is also the same room.
You will have the same equipment, everything will be the same, so yeah.
Maybe on this side, you can just follow into that. आपने अपने साथी लेके चले जाओ उधर.
What did you say?
Take a partner and go there.
So you are finding your it's a scientific partner. So basically, is it okay? You have somebody to work with? You have your okay, good. You're all set. Okay, so I guess we need to have the third one so that there is enough space. You go, please use the other side also. The one who are going to stay here, let's say yes. You go to the other side, and the last. Yeah, please occupy all the space. And try to be 1, 2, 3, 4. Yes. It's okay? How many are there? Right. So I think try to occupy the full space so that 2, 2, 2, 2, 2, 2. So 10. 1, 2, 3, 4. Maybe you can manage to be 10 here and 10 on the other side. It's okay, right? Okay, good. So then you will be 20 and then you take the full space. Yes. And we have a third room, you said? There is a third room?
He's bringing the key.
Yeah.
He's bringing the key.
Okay, this one.
You bring the key.
Okay, good. Yes.
Yes, sir.
So now you can install here. Okay. How many are you in this room? So you are 1, 2, 3, 4, 5. There is still some room here. I mean, if there is some people who want to come here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 20, 25 about ish. Okay, good. So I'll start distributing the full scope so that you can get started. It's okay? So, 1. Maybe you will be, I want to be sure that we manage to have before. Can you start being, can you work at the moment? Yes. 1, 2. 1, 2, yes. I hope I will have enough, otherwise we need to reorganize a bit differently. 3. We might need to regroup a bit because I'm afraid we'll be quickly short. 1, 2, 3, 4. You have one? 5, 6, 7, 8. 9. I think after that, maybe we need.
You have to handle it very carefully because you will have to meet tomorrow and day after tomorrow, right?
You can call me Daniel, I guess. Otherwise, I'll call you Professor also.
You should know how to use it. If you have any questions, please ask.
It's okay.
So handle it with care. It is a request to everybody.
So now there is the other microscope. Okay, so basically everyone would have. So you go online. There is all the info of how to mount it.
There are few in that room.
Okay, so basically we'll take now the yes. Can we start also taking the clips? Can we also give over there? It's okay.
अगर पता नहीं हो तो they should ask how to use it first.
Yes.
तुम उनको थोड़ा सा बता देना.
Then I'll check whether everyone has some because I think we need full scope. I distributed them all. I think over here they don't have any. So you're going to have these ones. You will have the group with the good microscope. So I think you have 4.
7.
You have 7. So basically you can 1, 2, 3, 4, 5. You can take one more so that you have 3. One more, and then maybe on the other side they miss some. It's okay? This room? Okay. This room it's missing? And also, okay, also on this room I think some of them don't have. All of them are done? Okay. Everyone has? Okay.
Do we need to give them any instructions how to? They will do it, huh? Okay.
I think so. You're okay? Everything has. I think it seems to be okay.
Yeah.
So just you give. I'm sorry. We have another different. Where is the student of
There are four more. Then this is this like for
who was asking for the extra one? Everyone has a microscope? Yeah. Otherwise, I'll make sure.
give me mobile. In your hand. Click over here. Okay. See, this is the slides. You have to put your sample here. Okay. Give me mobile. First, select which one is. There are two cameras. No? Which one is your primary camera? So, put your finger here. Okay. Then so the first one is your main camera. Okay. Then just camera. Also, then turn on your LED light. Then you need to press. Okay. I'm just just for support. Then this is my sample. It is on water. Okay. Now I want to see the microbes present inside the pond water and try to analyze the Brownian motion MSD by using some already prepared software, or you can say script. Okay. This is cover glass. Okay. After putting your sample, just place above your sample. Then okay. Just below the objective lens. Okay. It is in 100x. Now I am increasing the magnification to 250. Then I am focusing using this one. Okay. You can see there are many microbes present here. Okay. Now by making some videos, just and then I will calculate the MSD and Brownian motion by using some algorithm. Okay, by using this videos. This is a simple experiment.
As Brownian motion depend on the viscosity also, na?
Yeah.
So if you take the pond water and if you take another water, it's normal
Then
water,
the Brownian motion will be different.
then is it any specific you are taking pond water?
No.
Just
yeah.
for the microbes or no?
It is different for different source of water. If you take the tap water, maybe the microbes not present in that tap water, it is also possible. Or you can take from the water cooler. But it is the possibility of getting these microbes is maybe yes or no.
Then we can say
That's why we are choosing here the pond, because the probability of finding the microbes is high in that particular water.
then we can't normalize the MSD in all the
Yeah, we
Can't normalize.
The theoretical part will tell that direction will tell about the theoretical. Okay, यार करना चाहेंगे? You can handle individual.
Have we seen that?
yeah, like that.
What the opposite side?
Yes. This I'm going to show you in 1 second. It's going to actually, when we're going to, I think you're going to put it here. Right here. I will read it to you. That's the triangle. That's the feedback. But we need to prepare the sample. And then we need to prepare it. Yeah.
How is yours like? How is yours like?
The sample we need to prepare the next. I just want to make sure that you first assemble the mic. Right, everyone have the times 50. So don't look at the sun. The only thing that I'm asking you is that don't look at the sun, because that will focus the ray of the sun onto your eyes, and this is very dangerous. So never ever directly to the sun. RTS and or inline. I'm going to continue to distribute this, and then we need to prepare the sample. If you find a way to stabilize it already with your cell phone, that's a challenging one, because if you move, the moving will have also the motion of your hand. So try your best to,
If we have magnified something, what we will observe?
that's the motion. No, we're going to give, we need to follow it. So we have coloring 3 micrometer in size or 6 micrometer in size. We're going to prepare the sample. Then you need to observe the sample. And then once you observe the sample, that's going to take a bit of time. There is also some LED, so then I will distribute them if we need them. We'll see after. There is also to have a way. Otherwise, start playing with it and then we create a sample. Everyone has a time 50? Okay? Yes, sir.
Oh.
Everyone has the times 50 or not? Okay, one comment about the light. Ladies and gentlemen, never look at the sun directly. Okay, so basically, if you now, I think everyone has mounted. You are extremely quick. That's great, but don't place the full scope directly straight to the sun, because that will focus the rays right onto your iris. Right. So never ever. Right. I have some LEDs. I have some LED. So if you miss light, you can add the LED so that there is more light, and I will distribute them in a second. Right.
So do they know what is this for?
Yes, so basically you're going to have 3 objectives. The objective that you had in the original package was time 140. It means that it magnifies 140 times, and below that it's written numerical aperture. Back on the envelope, a numerical aperture is the angle at which the objective takes light. So a large numerical aperture corresponds to a large light like this. A small numerical aperture is a small light. So the larger the numerical aperture, the better the resolution. But it's a trade-off, because if you have a very large magnification, you are not necessarily have a large numerical aperture, but you might. But then if you move a little bit your sample, in addition to the Brownian motion, you're going to have lots of motion that will be disturbing your measurement. So it's a compromise. And this compromise, you will need to decide how to make it. So you're going to have 3 objectives. 140 is the one you had. 340 is the one I distributed before. 50 is the one that I'm giving you now. Keep it for the entire week, because we will need it tomorrow again, and probably also the day after tomorrow. So everything should be kept very carefully.
Maybe we recollect today.
You know better than me what's
because
best.
Sometimes somebody may not come, or what something
Okay.
happens. It is better we will recollect it tomorrow and redistribute.
Okay.
No problem.
If because
Yeah, that's better.
tomorrow we're going to see a real organism taken from water, and so we're going to make a difference between particles and real living cells, right? And so the idea is that you reuse what you've been preparing today, right? So I'm distributing these, then the LED, and then we prepare the sample. When you manipulate them, I take the metaphor that I make of some of you. In your camera, in your cell phone, probably you never put your finger on the camera. If you do, stop doing it, because if you want to keep your camera for a long time, it's better never on an optics to put your finger. It's like the eye. If I put my finger on my eye, I won't see much. It is the very same thing. This is essentially a lens. So when you manipulate them systematically, you manipulate them on the side very carefully. Okay? Good. So I'm distributing them, and I'm back in a second. You're welcome.
Again, please use with care. If you have any questions or any doubts, please don't hesitate to ask. Because the instrument is very important. We also have to use it tomorrow, so use it with care.
Oh no, you don't need. Each time I'm making the mistake. Time 15. Okay.
What happens next?
The preparation of the sample.
Okay, nice.
It's going to be the 3 micrometer colloid.
Okay, polystyrene beads.
Polystyrene beads.
Oh, nice.
Probably you did already this experiment, no?
I've worked with optical trees.
Yes. So for you it must be boring, but. And you also did such experiment before.
I am a theoretician.
Okay.
Molecular dynamics and
So it is your, yeah. So you have an expert in optical tweezer next to you, so you can. It's okay? So this is another objective. Another objective. And I'm coming with LED in a second. So far, so good? Okay.
Pond water we have done.
No, you should start by non-pond water. Pond water is not today. Today is only the colloids. That's it. Yeah. I mean, it's okay. You have advanced. It's very good. But at the moment, if you could go very slowly through colloids, but you will have in advance. But let them go very, very slowly. The idea is the more they discover by themselves.
That one is assembled by me.
Yeah, sure. But for the sample, it's. So I'm going to distribute the LED. Be careful, the LED have a finite life, so you switch them off when you don't use it. Okay? And you have an on-off which is on the side. So you don't need that. You don't need because you have already. This is the LED to put some light. LED to put some light. You have already.
So can you please explain
Sure.
this process?
The preparation of the sample?
Yes, sir.
This will be right next. At the moment, I'm distributing the light and then I'll. Yeah. So you need.
have that bigger one.
You have this, okay?
This is a switch. Okay.
This is LED.
When you remove it, it will take
Pictures of the sticker.
Yes, very good. So it's exactly what. That's the point. So the whole point. Yes.
It's LED.
Yes, it's LED. Just so you have more light, so that basically you don't need to point it to the. Okay. You see something?
Yes.
That is the whole point. You can take tissue, anything that you find in your environment, and start imaging. This is the light. You see here with this, you should remove this guy, and then after that you turn on and off so that you have light, so that you don't need to point to the. Yeah. All right. So try to put the LED. Try to put the LED so that you have light on the other side. Okay. Right. So I'm going to distribute you LED, I mentioned before, so that you replace the light from the sun by a source of light. Be careful, it is with battery, so switch it off when you don't use it. And you can play with it, there are different positions. I mean, it's fun. Actually, when I was preparing the practical, I was amazed that it would work.
Okay.
Because I thought I would not see anything. And all of a sudden, wow.
Where you have to put it?
On the other side.
Okay.
Basically, this is the natural source of light. You don't have one? Yeah. Everyone has a light? Yes. So I think we can prepare the sample next. Remember to switch it off after?
Yes.
Okay. So this is the light, source of light.
Are we connecting it right?
Yeah, you have thousands of ways of doing it. So what you do is probably right. And if you want light, this is a way to put the natural light on the other side. Okay, so you need to remove this to have the battery on, and then you put the light behind it. Okay? Sounds good? So far, so good? Okay? Good. You know where my false copy is? The one that was mine. Where is it? This is mine. Can I take it? Thank you. This is okay. You have one or not? Okay. But then I'm.
It's not folded properly.
This was you're done with it or not?
No.
We tried to assemble it and
You did not manage.
Yeah, then we tried to use it.
Okay. Would you do me a favor? Could you manage to assemble it or not? Could you help your? Okay, girl. Sorry, I keep it for me. So, but this is yours. This one is yours, I guess. Yes.
Do they know how to actually flash a light?
So I'm going to show them, but I think I will explain to them.
Yeah, because
Otherwise, they go on internet.
because they will experiment and break it.
You think so?
Yeah,
Okay.
yeah.
Right. So let me show you. Let me show you how to use it. Otherwise, you go to internet. I think there is some flash code on the paper. How to use it. Otherwise, you simply remove that so that the battery is. And then once you have removed it, you press on the light, and then you will have one,
We're trying to figure
2,
out
3.
what they could not
Okay.
find.
Okay. Easy. This is from who? And I find it very clever because if you put it on the back, this is yeah,
like that?
and there is a magnet. So basically, it fits it exactly in the axis.
Okay.
I find it super clever.
That's the aperture.
Yes.
Okay.
It's not.
it was sticking.
It was sticking.
And
I'll be back. What do you see? You're observing what? Do you see motion or not? Or something? No? Okay. So, we take some time. What do you see? You prepare colloid.
Actually, they didn't mix this one.
Okay, so the real life of experimentalist. We're going to prepare samples. Yeah, you're okay? Thank you. You managed to manipulate the light? So then you need to place it you need to place it in the scope, on the scope, right?
Yes, 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 I can. This one. This one. उसके ऊपर.
So you see, for instance, you see here, it's placed automatically. I mean, this is the same one that you have. So basically, you see, if I have my objective like this, I have the objective on the one side, and I have the light on the other, right? So that I don't need to look at the sun like this. And so basically, if I take this up, I can remove that. Don't forget to switch off the light. We're going to prepare the sample. We're going to make the sample, and we're going to place it here. And then we'll observe on this side. And we'll be moving the sample like this. X, Y, like this. And we'll be able to change the objective. And the last bit, which is not totally easy, is that we'll be able to make the focus by moving this. I'm going super quick, but I guess you figured it out by yourself
Up and
already.
down and sideways also you can move it.
So it's very in every direction. Be gentle because it's paper, right? But if you can play with it, and then we prepare the sample of colloid. Okay?
Yeah, if you explain them, they will not
Break it.
otherwise, yeah.
But
there
my
is chance
impression is
they
that they manage to do it by themselves.
yeah, they will do it. But little bit we have to instruct.
Otherwise, okay.
Otherwise, they will experiment and break.
Okay, sounds good.
That's right.
Sounds good. Okay. So far, so good. You manage. Everyone has the. Do you want me to show you a bit, or it's okay?
Please ask question if you have.
Maybe I show you one last time, and then we prepare the sample. So I'm coming with one, and I'll show you.
कैमरा इसके ऊपर आना चाहिए.
So basically, this is the full scope that you have now. On the one side, you have the objective, which is here. Basically, it is the small item. You have three now in your hands. If I'm taking it out, you have essentially different parts. You have this part. If you lift it up, you can place here the sample we're going to prepare. And we're going to prepare it in few minutes, right? So you will have colloids to observe. Then you will insert it here. You will close it so that it's firmly tight. And then wherever there is some fingers, there will be some figures actually, that's where you should put your finger and move the sample up, down, on the side, like a stage on the microscope. Now you will have to make the focus. You know, like in your camera, you want to focus on a different point, or whenever. So it's very clever because they made here a piece that have a varying thickness. So if you want to change the focus, you simply glide this piece actually, and you will make the focus. And the last bit is that on the one side, you will have the objective, which is right here. Either you use the light of the outside, or you use the LED, which are here. And cleverly, they put also a magnet, which you can place directly on the right spot. And it will fit exactly in the right spot. And then you turn the line on. And basically with this, you will have the light directly coming through the sample, going to the objective, and then to your cell phone, and you'll be ready to acquire. Is it clear? It's okay? So if you can try to make it, and then we prepare the sample. And
We should not touch the sample part.
yes, so basically, never ever you make your finger on top, because it's the same thing as before. You will damage the quality of the signal you will have. Okay? Good. Right. So now I have 3 micrometer beads colloid. Have you seen on internet how to prepare the sample or not? In principle, in your kit, you have this is your kit? Yes. In your kit, you have you have this type of card, blank card.
Yes.
You found it? And did you find on internet how to mount it? Anyone? Okay. Anyone has found how to mount the card or not?
We have seen the links.
I think the link is on the paper, probably. Look.
If there is any link, maybe you have to open that and see.
Open the link, and then what you will have to put is that you will put the black ring. You know, there is a black ring that will be on the one side, and there will be some sticker on one side. Go please until the moment that you have still the chamber open. I'm coming with the sample, I put the sample, and then you will close the sample. All right? First, maybe, can anyone try to go on internet? I don't have internet right now, but can you go on internet and try to find how to assemble this guy? And then we go from there. You need to find how to mount this card.
Some link is there in the instructions. वो कैसे mount करना है, उसकी link है. Maybe YouTube पे video वगैरह होगा.
Yes.
You have to follow that link.
You can follow this site.
That's right. Yes, you go to fullscope.com. I mean, there are many links, actually. Yes, fullscope.resources, and then you see how to mount it. Right. It's okay? They manage? Okay, on the other side, they are mounting very little by little. The idea is that they learn optics at the same time. So
And
maybe
to just search the process how to mount.
yes, yeah, that's right. So it's yeah,
Internet.
it's internet, and then to mount the optics, what is an objective, what is light, what is what is numerical aperture, what is it's microscopy. Right. So if you can start assemble the sample in your kit, you have a sample which is a card, and after the card there is also a black ring, and there is the card, the black ring, and there are two stickers on the one side and stickers on the other. So please go on internet to find the mounting, and then I will come with the sample and I will put the colloid in your sample. So before you close the sample, I'll come and I'll put a little drop of this colloid, and then you will be ready to go. Okay?
Is it micro?
Go to fullscope.com, and try to find the link to mount the sample. But don't close the sample, because I need to put the bead inside your sample.
Don't touch your sample part with your finger. The sample part has to be very.
So yeah, if you can mount the sample, if you find the yes, the LED is not. Yes, this is here.
But you don't have any.
I think I gave all of them. You don't have LED? Oh, sorry. How many LED? Can you raise your hand, the ones who have an LED? Is anyone not using the LED? Anyone is not using the LED?
Will manage without.
No, but I'm sure there is the same number. That's why I'm saying that it has to be. No, otherwise I'm sure there is. All right. So please prepare the sample and don't close it so that I come with the sample. All right? It's okay. You have your. Where you are here or here? Here. You're good. Okay. So I'm going to prepare the sample. All right? Who has the LED? Who has LED here? We miss one LED. Who has? Can you raise your hand? The one who has this? How many? Raise your hand. Oh, do you have two, or do you have? Who has one extra? We miss one. Anyone miss? Okay. Okay. You are. You are using it?
Yes, sir.
Okay. You are using one. Okay, good. When you are ready, I put the sample. You are using one. You are using one. One. Okay. Okay. Good.
उसको रखो नीचे
I found one. I found one. I found one for you. Right.
how do we use it
This one? So for this one, I will ask your colleague. So you don't, but you don't need one actually. Here, you are not using a full scope, are you?
No, sir. No, sir.
So I'm going to take it back.
Okay.
Okay. Did you start using it or not? Yes, that's it. So basically, there was an extra one here. So that's it. So I'll ask the other colleague and then I'm coming. Right. So you are ready to, so that I can put the sample or not? Are you ready so that I put?
We need 5 minutes.
Okay, good. No rush. No rush. You ready so to prepare the sample? Can I put the sample or not yet? No, you're not ready.
The sample now.
You take your time. You think. You meditate. No rush. You need to use this. You know where to place it.
Not so.
Not so.
Start.
Take your time. Yes. Oh yes, you have the extra one. I will go on your bench. Okay, let's go. So you call me whenever you're ready so that I give you the sample, right? All right. So you put it on the bench. So you agree with me that you don't see anything. I mean, it looks like milk, right? Okay. There we go. And you close it. You are ready also? Yes. Okay. All right. Who needs colloid? I mean, this. You agree with me that this looks like it looks like milk, right? More or less. You want? Not yet. I think you need a bit of time because you need to prepare the sample. In fact, what you need to do is to put a ring. That's right. And then it's on the internet, they explain, and you put the 2 stickers on the one side and on the other, so that if you wish, it's a chamber. It's an experimental chamber. That's right. Yeah, yeah. If I were you, I mean, when I was preparing it, I went to internet and you type full scope mounting and the assembly or something. And then leave it open so that I put the drop at the end. So you ready to?
So we have the microscope.
Yes, you manage or?
We have asked one senior, so if he will
Okay, could you try it by yourself? You have the samples or not?
No, we do not have the sample. We
Okay.
have the slide.
Yes.
I think we have to put the sample.
I'm going to put one. Okay. Okay. Good. You need a.
Yes, sir.
Okay. Yeah, very good. Maybe you put it on the table. You see that it looks like milk?
Yeah. Yes.
It's not. Okay. You ready to go?
No, sir, we are doing it.
Okay, no rush, no rush. Take your time. You ready to go? You're getting close. No, you're good. You're good. You put the sticker on the one side or on the two sides?
One side.
Okay, so good. Let me put the drop. I will put the drop of the sample, and then you're going to seal it on the other side. Okay? And you're going to seal it with the other sticker. That's right. Before I go to the next room, is it... oh, okay, right. You put it on the table, I think it will be more stable. Okay? You see something?
No, sir. We have the sample.
Okay.
I will try 1.5.
All right, sounds good. Yes.
Everything can be reused tomorrow?
Yes,
Everything?
everything.
They cannot throw anything?
No. And they should keep everything. Yes, you need a sample. Yeah, maybe you put it on the table so that it's in your table. I think it would be easier.
What is this colloidal solution?
This I won't tell you. Okay. Any sample needed? So this I'll show you next. Your sample is ready or not?
No.
Oh, you need to prepare the sample first. Yeah. Your sample is. So you need to put the O-ring. You need to put the black ring in the way. If you have a doubt about mounting the sample, you go on internet in the full scope. It's okay? You ready to go for the...
Yeah.
We have to put a sticker on the side.
So put a sticker here.
So at the moment, no. Do you have the chamber? I will put the beads. I think I didn't give the beads.
Okay.
And then you put another sticker on the other side.
Okay. On the other side.
That's right.
Okay.
Okay. If you want to put it on the table, I think I will be more comfortable. It's okay?
Yeah.
If you want me to center it better, or
Yes, if you could.
maybe you put on the table.
Yeah.
I think I will be.
Yes.
Right. You're okay? You're okay? You start saying something? Okay, good. Your sample is ready? Okay, good. Everyone is, so I'll go on the other room then. Everyone is ready for the sample or not? Okay, so I'm going to give beads. I gave you the beads.
Film is on.
I gave you the beads or not?
So what?
I gave you this or not?
No.
So I should give you this. Basically, you should have the colloids.
It is ready to take samples.
So, yes. So basically, just 1 second. To prepare the sample, you need to take this card, right? I mean, maybe I can take your card here. And if you go to internet, you will see that you need to put a black ring on it, a sticker on the one side, and a sticker on the other. If you wish, it's a sandwich that is going to allow you to have a volume. And whenever you reach the stage that it is still open and about to be closed, I'm going to put some beads inside. But for this, you need to tell me that you need the beads, right? So who needs the beads? Yes? So you call me, I give the beads, and then you will start recording and take your time to take movies, and then we're ready to go. Okay?
Sir, there is also sticker. We have to power it out.
You put it on both sides. You remove one of them because it's a sandwich. Very carefully. Maybe take your time. And so you have the other side. Will go on your table to be safer. Okay. So you put it on your table because I would be more comfortable to manipulate if you place it. Yeah. Okay.
We need to cover it all.
Yes. Anyone need a sample? Okay.
We need samples.
It's open or not? It's open, right? It's not closed. So put it on the table because it will be easier for me to manipulate, and then you will close it.
Same sticker.
Yeah, whichever sticker you find will do. If you could put it on the table.
The clear sticker is here.
Sure.
And the ring is here.
Yes.
We put sample here.
Yes, and then you close it.
Then you close it with.
Not the sticker. Yes, that's right.
Okay.
Put it on the table. I'll be more comfortable. Okay. Can you put it on the table? I'll be more comfortable too. Okay. And then you put a sticker to close. Yes. Whichever. I mean, one that closes. Sure. So it's open?
This is set.
Yeah. So basically, if it's open, it's fine. Put it on the table, I'll be more comfortable too. This is 3 micrometer beads. And then you close it. Okay? Anyone? You want beads? Yeah. If you put it on the table.
Sir,
Yes?
can you please tell us?
Yes. I will put it just. Oops. Yeah. I'm sorry. Yes.
How to place it?
So this I'll show you next, but you need to close it with another sticker. So you need to put 2 stickers. It's a real sandwich, right? You need to close it. So there is a chamber below, there is a surface below, a surface at the top. Ideally you go to internet and you see how to assemble it. But the bottom line is that you have a plastic at the bottom, you have a spacer, and then you have the other sticker. Okay? Anyone wants beads? You need beads?
Does it matter which
Sticker
side
is
we have to pick?
upside.
It's okay, it doesn't matter, you'll manage. I think you'll manage.
We can put.
Yeah, you'll manage. Okay. Okay, I think you need beads, okay.
Is this the correct one?
Anything is correct.
We can put the bead here and we'll paste a sticker on top.
Okay. You need beads?
Sir.
Yes. So I will go to your table so that you can have a... It's okay? Yes. Do you see something?
There is no motion.
There is no? Ah. You start seeing something. Congrats.
There is no motion of particle.
Not yet. Record, and try to move around. Okay, who wants, you have beads or not? You have the sample? Okay. It's open or it's closed?
It's closed.
But I need to you put the beads already.
It's closed.
But I don't, so you need to open it.
Now it's open.
Okay. So maybe you put on the table, it will be easier for me to place. and now you're going to close it. I'm sorry? Passive. You observe already some particles or not?
Yes, yes.
So you know what you're going to see. Okay. You need. All right. So please remove it. And you're going to close it after with another sticker. Right? Yes, that's right. Yeah. So if you want to put it on the table, it'll be easier for me. Okay? But it's. No, but here there is. Okay, you can put the black, one black on top of it. Yes. Right. So you go on the table. Okay? Sure. You have to press it, yes. Can you go on your table? I'm coming on your table in a second. Anyone? Okay, you want? Yeah. There is to have the hole, right? Yeah, that's right. I'll coming back later. Anyone need some beads? It's okay? You're okay? You need beads? You have, okay. Right, and then, well, you can start recording now. You have some beads? Well, change objective. You have 3 objectives, so you need to play with. You have the sample, it's okay?
Yeah, looks like we've
can
got
see with the
So it starts. Okay. And you're going to like an optical tweezer and then you will travel.
we don't see the movement.
Okay.
very slight. What we see is the drift.
So the Brownian motion, can you zoom in? I took it. I could with the one of the objective.
okay.
Yes. So just play a bit with the objective. Yes. You need. Congrats. What? There is Brownian motion here. No, don't move. No, please come in. You can. Everyone will manage. Yeah, that's the whole point. Anyone needs a sample? Anyone needs a sample? You have? Okay, so I'll go to the next room. You're okay? In fact, you were lucky because you had something already mounted. I invite you to go to the other room, right? If it's okay, because you see a bit because they mounted the microscope from scratch, and anyone needs some beads? Anyone needs some beads? You okay? You're getting close. There is something strange. Yeah. Yes. Anyone needs some beads?
No, sir.
So I think why don't you group? You go to any group and you try to see what they do. Okay. Right. Anyone needs some beads? Yes. So you need to have a sandwich so that there is space for the beads. So yes, you put this. So I'm going to put some beads, and then you need to put a sticker. That's right. So can you put it on the table so that I will be more comfortable to. That's right. Okay. Right. Anyone need some beads? Anyone need some beads? It's okay. You wanted some beads, I guess.
We got.
You got? Okay. So it's 6 micrometer beads. Okay. So if you want 3 micron, I have 3 micron. Okay. Right. Try to incorporate the one who are in another group with the microscope already mounted. So I think you need to impose yourself. Just to say. All right. Anyone need some beads or everyone has beads? You'll be needing beads.
1 minute later.
Okay, 1 minute later. Good. So you call me whenever you need. You're all right? You're okay? Okay, good. You start seeing something? You're getting close. Right. I think you. You're starting to get something, right? Okay. It's okay? Right. All right? It's okay?
Yeah, almost.
You got...
It's not focusing correctly.
Right, so play with the... Right, so I need your attention for a second. I need the attention of everyone for 1 sec. I invite you, 1 second. So I think everyone has the beat, right? So basically now I'm done for this. I would like that you try with different objective, times 50, times 100, times 340, and you try also to zoom with your camera. And ideally, I would like to ask you to what do you see essentially so far? What do you see? Brownian motion, right. So I told you, this is just, it looks like milk, but whenever you go with a cell phone and a simple microscope,
Just keep quiet. Keep quiet.
you can have Brownian motion. So the step that I would like to ask you is first to have fun with it, because it's fun. It's not expected to see a particle. This is matter. This is inert matter of this morning, right? And you see that it's moving. I saw many of you have already a beautiful picture, right? So try to acquire a movie with the best resolution, and ideally not global motion. So it should be basically, you try to stabilize your RSA, and you try to record, let's say, for 1 minute. 1 minute is very long, right? But if you have a movie of jiggling particles for 1 minute, or even 5 or 10, whatever you manage to do, then we'll try to analyze it either today or tomorrow, right? But you try to acquire either 10 movies of 1 minute, but you should be very cautious, because if you have the slight unbalance, you will see a global motion that will ruin your measurements. All right? Bear in mind that there are 2 samples circulating. From me, it is 3 micrometer beat, and I think from Soban, it is 6 micrometer beat. So mark carefully which one is which, and when you make the measurements today, this evening, this night, or tomorrow, we'll compare the results between 3 micrometer and 6 micrometer beats. All right? Have fun. It's okay? It's okay? You participating to the... No, it's okay. Yeah, sure. Do you want to put on the table? Yes.
Does energy depend on the viscosity?
Yes.
So, we can normalize that for any simple microorganism, or that we are taking this is the MSD for this microorganism, because it depends on the different butters also.
Yeah, so then you have a problem, because we change 2 things at a time.
Yeah.
We'll talk about it tomorrow. Okay? Yes. Can we be on your bench? Sure. But I prefer if we are on your bench, on the table. Yeah. You saw the movie? You saw the movie?
Yeah, so very nice.
It's amazing that
The size is very homogeneous.
Yeah.
Very similar.
You want? So if you want to put it on the table. To put it on the table. On the table, I prefer on the table.
Here on the except.
It's okay?
Oh, yes.
Right. So you're okay? So I let you see it, and after that I want to see the movie of everyone, right? So I pass by.
Yes. 3 micrometers.
Sure. You want some bits?
3 micrometers.
It's open or it's closed?
It's open.
I see it closed. It's open. So maybe we'll go on your bench. I will be more comfortable to. Yeah. Where is your bench? Okay. You put your. There is. It's open.
This is 3 micrometer or 6 micrometer?
This is 3 micrometer. I don't have 6 micrometer, but actually somebody else has 6. But you took movies already?
Yes.
Can I see?
Okay. Yes.
Aha. With movies. Look, you need to take movies, right? To measure the MSD, you really need movies. Right, but okay, take your time with the 3 micrometer. Basically, in the movies, you need to take movies which are extremely stable. So it's going to take time. You know, take your time, breathe. You know, there is no motion, nobody, you know, and it has to be extremely stable. Otherwise, your measurement will be wrong.
What about the fluid moving?
This is what you need to prevent. You need to find a way to stabilize. Yeah.
This is open.
Good. Okay. Anyone?
But we can observe in the seconds.
What do you say?
We can observe in the seconds only.
It's okay. It's a good time scale.
It's good time scale, but
You got to go until a minute, 10 minutes. You can measure during an hour.
in the school we are taking like second. There also time scale is second.
It depends on your resolution. Here, the resolution of your cell phone is about sub-seconds. You will see that the MSD is reasonable.
Because like if we go in the nano time scale.
This is agree.
Not possible.
Agree. But for this type of beads, that's the job. You end up with the right number.
That's the
Right. So I'll go to the other room. Everyone has beads, right? So try to record motion. Try to record motion without global flow. So it has to be a motion stable for the longer the better. So at least 1 minute, 2 minutes, 5 minutes, 10 minutes, right? With no global motion. Right. Did anyone take an extra LED? Did anyone take an extra LED? Yes. Yeah, it's becoming good. It's becoming good. Try, change objective, try to play with the system. Try to play also with the focus. Did anyone take one of these? Sorry, did you borrow one of these or not?
Yeah, one of because ours was not working.
Yes.
You took, okay.
It's not working.
Okay, because you didn't remove that guy. So I'll take this one and I'll take this one. Sounds good? Right. So this is silence. It's very good. It means that is it working? Yes. Who has Brownian motion? Right. How long did you manage to take Brownian motion?
5 minutes.
5 minutes? Until I came? Is it global flow or is it a real? I mean, basically, did you manage to have stable? Is it stable or is it moving all around? All right. Which objective are you using? 340. All right. 340. Did you also change the focus? Basically, did you needed to change the focus a lot or not? Basically, you know how to change the focus, right? It is the point that you're using. Okay, good. So try to record as long as possible, and try to record as many particles as you can. And the last thing is that try also to take many places on your sample. Probably you will have places of your sample which are extremely dense, and other places which are not very dense. And so you're going to see that this is going to affect your measurement later on. Why? If you are very dense, what's going to happen? When the particle moves, what it will do? It will it will collide, right? So basically, try to evaluate your measurement with respect to the local density of colloid. All right? I'll pass by and then I'll see your movie, okay? But it sounds good. Apparently, apparently it's working. Yeah. Okay, yeah. And you can use also the zoom of your cell phone if you want to have an extra magnification, right? It's okay?
Sir, I need 6 micrometer.
6 micrometer bead. So 6 micrometer, I think, you manage? I think there are some people asking for 6 micrometer beads. Do you want to give to?
How do we put it?
Yeah, it's working.
So tomorrow they will analyze.
Analyze and take the pond water. Take the pond water and compare the pond water with this one.
There they will have a different live or living organism.
It will be a living organism. And the idea is that they distinguish passive particle from active particle and what is the difference by their observation. And then we begin to build little by little.
It's very nice.
Thanks, it's fun.
Yeah, it's fun.
I mean, I didn't think it was working, and when I received it and I was trying to make it, I said, well,
It's good that you got the photos, otherwise
yeah.
they would not have been able to see.
I think it worked for everyone. I didn't do everyone.
Almost everybody.
Good. So you manage? You have movies? I want to see movies. Yes. Very good. Perfect. Can you zoom? Perfect. How long is it?
It's around 10 minutes.
Okay. Can take longer? You can 6 micrometer is over here. You can. Can I see your movies? You have movies?
So there is no focus number available. Actually, we were in the next level.
Okay, so can I see still your movie? You have your movie of particle, can I see? Can you zoom in? This is a particle or it's a small organism?
Actually,
Yes. This is a particle or this is water for pond?
water from
Okay. Did you have a look already at particles or not? Okay. I have an extra foldscope. Would you like to do it on the foldscope?
Yes.
Okay, I think it will be fun. So why don't you do it? Well, stay here. I will bring it. Right? So this is mine. So careful. I will take it at the end. If you want to separate it from the rest, so that so basically this is the foldscope, right? And well, I think I have a card which is already ready, so you can. It's a build. Well, it's a bit old. I think I prepared it in France. So it's on this one. I think it's this one. This is dry. Yeah. One of you has a cell phone? So this is basically the sample on which you can deposit the beads. So if I manage to remove this guy, I need an extra. Maybe you take one of these here. Yes. And the paper over here. Yes. And so you're going to prepare a sample. So you put one of these here, and you're going to take a sticker on one side, and I will come with the bead. Okay? Otherwise, you look on internet foldscope, and then I will help you to make it. First, prepare the sample. Okay? So I'm coming with the bead in a sec. Yes. You need a sample. This is open?
Yeah, this is open.
Can you go on your bench? And then I will go into... It's too concentrated? It was frustrating, yes. I see what you mean. You know what? We do it, I'll put a little drop, and then you put water, right? You want to put it here? I will take a look at your movie in a second, right? Can you put water, right? A tiny bit of water somewhere. Anyone needs a bit? It's okay? Good.
Can you see if you're making a
Sure.
This size is in micron. What?
3, so you have 2 beads circulating. Remember which size? 3 micrometer comes from me, 6 micrometer comes from Pramod. Pramod, 6 micrometer, from me it's 3 micrometer. A factor of 2. A factor of 2. You need beads? I will go on your bench, okay? I'm coming. Okay? Yes. So do you want to put on the table? To be easier. Can I? Do you want to? Oh, you have beads already. Or 6? This is 6 micrometer or 3 micrometer? So this is you have already. From me, so 3. So you have already. It's okay. Right. Nice, no? Nice, congrats. How long is it? Isn't it amazing? Why is it moving? Why is it moving?
Motion.
Why? Why? Collision of what? Yes, but there is no particle here. No, me too. Just it's basically particle of water, which presume. But first of all, it's very strange because if you take a look at it, it looks like milk, right, essentially. And so basically, the fact that it's moving is very strange. That's what I was trying to say this morning. Is that it's fascinating that it's moving. And so the idea is that there is the water molecule which are giving some shock everywhere in the particle, and that gives this motion. But this is beautiful. You see? Good. I'll let you. How many movies do you have like this? How long is it, the movie? 20. Wow. 20 minutes? Okay. Very good, very good. So we're going to analyze this movie also, right? Good. Is it okay? Yes?
Actually, I think this is of my friends, but this is ours.
Yes.
What we are concluding from this, that might be possible that our solution is a bit concentrated.
Yes.
The reason for which it is coming like that. However, my friend is coming like this.
So what it changes the objective, no? You can change the objective, and you can also change the magnification. With your cell phone, you can increase, and so and you never manage to this resolution.
No, almost it's coming like that. This one.
Okay. Can you try again?
Yeah.
Still, you give it a try. Okay, I'm back in a second. Right. Who needed beads? There was one person who wanted to have beads. It was where? Okay, good. So you're ready to go? Okay. You have the sticker? Yes. So then I'll show you how to do things. So it's pretty concentrated. Okay? So now you're going to seal it, and then you will put it inside and you can observe. So you seal it with a sticker. That's right. And then you're going to put it in the foldscope and you will be ready to go. Okay? Right. There was somebody else who wanted some beads. Who wanted beads? It's okay? No one? Okay. Oh, you want?
The other one.
The other one, it's Pramod who has it. I will look for him. I don't know where is he. 6 micrometer. Yeah. Okay. 6 micrometer. Pramod, where is Pramod? Oh, there is 6 micrometer candidate. It's okay?
Yeah.
You manage? You done?
Best
We have this one, then we also have this one.
Which resolution? Can you let it? How long is it?
1 minute.
This is nice. This is very nice. I mean, you're used to it, but okay. No, I'm sure you did it. But I'm saying that you're used to it. For you, it was a shock, for me, it was a shock.
Very interesting.
Each time I see that,
Yeah, but it's so easy to do these things. Like we talk about Janus particles and all, but like never thought of doing an experiment on it.
Because then it's not abstractive. That's the whole point. Yes. Yeah.
And this is the one which is more small.
But then you can.
This is the first one.
Yeah, and I can hear your reaction. It's good. It's 90% of the job. It's okay. You manage?
It is only 140x.
Can you try 340?
Yeah, I tried.
And-
It is motion.
And can you manage to zoom with your camera? Very good. Can you show me the movie? I'm coming. Let's show. To make it stable. As stable as possible. Beautiful.
340.
Beautiful. This is amazing. The only problem, which is not a real problem, is that you see that there is a flow. Can you try to correct for it? Can you remove it?
Flow. If the solution is concentrated.
Yeah, but there is another way, which is to have it perfectly flat. And then you need to adjust the sample so that the sample is really super flat. Yeah. So, and this is not easy to have a perfectly flat. Even if you have a big microscope, very expensive, there is always a drift. The drift is the nightmare of the colloid particle. So this is already good. If you manage to stabilize it, will be even better. I think you called me here, yes? It runs until 4:30. So we wrap up soon? We wrap up soon? Yes. I mean, there was one person calling me and then I'm coming, okay? Yes? This is amazing. So it's almost perfect. You know what I'm going to say? What is the problem here, potentially? Is that in addition to the motion, what do you have? I mean, first of all, is it surprising? Is it surprising or it's not surprising? Yeah, for you, is it surprising or not? What do you say? There is in all directions, yeah, but then there is a flow. If you would manage to suppress the flow, that would be even perfect. How can you suppress this flow? That's right. And this is difficult. Right. If you manage to do it, that's right. It is tilted a bit, yeah. Can you zoom? Okay, it's very, very, very nice. Do you like it?
Yes, sir.
Okay, why is the bead moving?
That is because of the motion. Brownian motion.
Yes, that we discussed this morning. Okay, so it's real, right? It's good. Congrats. You manage? Can you show me? I don't see the beads. Ah, see it. Can you zoom a bit? You have other movies? Yes. If you zoom, because I don't see the bead in focus. Can you record some more? Look, maybe can you yes.
How I can see the bead?
Is it moving? Okay, is it still on or not? You can try to have a longer movie. It's good, but I think it could be even better. You have movies?
Does this look good enough for the calculation?
I think it will do. Look at what you can have here. Okay?
We couldn't focus more than that. And 6 micrometer is already over, so this is with 3.
3 micrometer, that's right, yes. Very good, very good. So you see here, it's ideal if you could have this type of movie, right? With
We can take another sample and again.
you can take it in, yeah. I think try to do it and then we're going to wrap up. Everyone has motion? Yeah, you see that it's easy, right? It's, you can you show me? Yeah, beautiful. Everyone has it? Okay, so we're going to wrap up soon. We're going to wrap up in a few minutes and we're good. Everyone has it. Okay, everyone has Brownian motion?
Yeah.
There was a group here, the new group for full scope, where are they?
They move there.
Oh, there, okay. I'm back there and then we're going to wrap up, okay? Right, so, you managed? It's in progress? I think it's a shock. When you see that, it's like, wow. Wow. And you record, and which objective did you use?
Your one, no?
Yeah, but which objective did you use?
3 micro.
This is the size of the bead, and there are 3 objectives in this foldscope. There is time 50, time 100, and 340.
340 and 140 and 50x.
That's right. And here, so use the one with which you are the most comfortable. And then you record movie, and in the movie you should see Brownian. You're going to see the motion of the particle, and the longer the movie, the better. And try to prevent motion. I mean, there should not be too much drift.
How many number of particles are ideal in a given movie?
That's a tough one. If we go to 100, it's good. Now, I think we won't manage. Basically, it's random. So basically, we will have a distribution of motion. And then when you average out, you will end up with a true mean square displacement that will give the diffusion constant.
But there is a collision also between the.
But there is collision. So basically, that's why you were asking for dilution. I think that was you. So at this stage, if we have back on the envelope diffusion constant, I'll be happy. I think that's good. The idea is to get, first.
So then we have to know how many micros is there.
That's right. Yeah. Okay, so I'll let you finish. Then we wrap up and we close, and we'll continue tomorrow. Okay. So you finish your measurements, and then we meet there. Okay. Right. So we're going to wrap up here in a second. In a few minutes, we meet on the other room and we conclude together. All right. So you can come whenever you're ready. All right. You want? Sure. 3 micrometer. Who wants? Okay, if you want to put here on the table, it will be easier.
Daniel, you have box to collect the lenses.
The lenses, actually, they should put it in the. They don't have. Yes, I can collect them. You're right.
Any box like this?
No, you're right. Because so that we can have them tomorrow.
Tomorrow.
That's fair enough. Yeah. So I'm going to. You know what?
Empty. These are empty.
No. In fact, we can put them back exactly at their spot. That's the best. So I'm going to pass through. Okay. So basically, they will. Maybe I.
You just
no, they can put it in the. No, they can put it in the box.
No, that is also fine.
They have one kit and they block the kit.
This is the way.
Can I see movie? You have? It worked? You had movies?
Have you recorded?
You have recorded movies? Can I see it? It's over there. Okay, good. Oh, so I don't. It's okay? Managed?
No, we just observed. I was absent for first half. I came in, tried to observe whatever everyone else was doing.
What did you see?
Sir, when I came, they were assembling it. And later on, they told me that we have to observe this Brownian.
But you are used to it.
Yes, sir, I have heard about it. So I observed it.
You observe it, you're right. Okay.
So today, tomorrow,
So tomorrow we'll see you at 10:30. We have tea now downstairs.
Can we wrap up a few minutes here?
Yeah.
It's okay?
We have 10 minutes.
Yeah.
I'm just giving them.
Okay.
We have some time.
So here the problem is that all the beads are flowing. Yes, this is better. Because you see here, you see the bead here? Isn't it trained? What is he doing? Can I? What is going on with the beads here? What are they doing? Just before we wrap up, first of all, everyone managed to see something? Yes. What did you see? Yes. Brownian motion. I was making. I think everyone was capturing Brownian motion. How would you qualify this motion? What did you see?
Displacement related to time.
Yes? It looks like what to discuss this morning? It looks like what compared to this morning?
Looks like what?
Yes.
Looks like diffusion.
It looks like diffusion, yes. What can you extract out of it? How do you measure it? What do you say? Stoke-Einstein. But actually, now that you have the movie, what do you need to do to get a number? You all acquired the movie, right? Some of you acquired the movie with 3 micrometer beads, otherwise acquired with 6 micrometer beads. So the question that I'm asking is that now that you have the movies, and successfully, and congrats, because in 2 hours this is great, now how can you begin to extract numbers? Because at the end of the day, what you want to have is a diffusion constant. You know, it's the Einstein relation I was showing to you this morning. So we won't going through those now today. I mean, after 4 hours, you must be exhausted. But actually think about it for tomorrow, or if you can measure it during this night, that will be even better. Try to measure the diffusion constant of the particle. So I'll give you one hint. You can download Fiji, which is probably some of you know Fiji very well. You can upload Fiji, and there is a way to track particles and to extract the so-called mean square displacement of the particle. So for those of you who are the most energetic, after tea or this evening at home, you take your movie, you upload them onto Fiji, and you track the particles. And tomorrow morning, when we will start the lecture, I will ask you the question, did you manage to measure the mean square displacement, and which diffusion constant did you obtain? Okay? We can make the deal? And the best one will have something, I don't know what, I just arrived, so, but basically, try to make the measurement, because I think if you start making the measurement, the analysis, the practical of tomorrow afternoon will be even more fun. Okay?
I sent you link yesterday. Yes. That link is talking about. I can resend them later.
And then you can.
All the links that you forwarded.
That's right. And so you can have it. One word of caution: in some of your samples, you were having a global motion of your sample. I mean, so some of you, I could see clearly that it was moving. So try to take the movie in which the particles are essentially doing this, very gently, very slowly, and it's very relaxing actually to observe because it's like, at low Reynolds number, right? Okay. So last thing before we go, I would like you to close, I think what we agreed upon is that you close your foldscope, you put it on the folder. We will need it really tomorrow, the day after. So try to pack it very, very carefully so that there is the 3 objective, all the samples, everything is wrapped. Also the LED, don't forget to turn off the LED. You see here, there was the button on and off. If you leave it on, we won't have LED tomorrow, right? So be absolutely sure that it is off. And if you can come and I will collect them here. I think somebody started. It's already collected. So maybe the LED, you do the same. You come and you give me the LED remaining. And
LEDs are collected separately.
Separately, right. Any questions, comments? It was fun?
Yes.
Good.
So, how do we, most few of us zoomed in the camera?
Yes.
And the size also changed.
Sure.
Yeah, so.
What is the scale then?
Yeah.
Yes. So the beads that I took from Strasbourg are 3 micrometers in diameter. The beads from Pramod are 6 micrometers in diameter. So today we know the size of the particles, so we have a scale bar, right?
Yeah.
Tomorrow we have pond water. That will be another game, because then we will need the scale bar. But at least for today, you know the size, right? 3 micrometer for me, 6 micrometer for the beads of Pramod. And I'm happy to continue to discuss downstairs around the tea. Okay? Sounds good?
Yes,
Good. So see you soon with the tea, and bring back the lead, right? Good.
Well, they will need to have anything in the seminar room for laptop or anything.
I think ideally, if you manage to have the analysis done by tomorrow morning, that is ideal. I will continue with the chalk talk. I think it's better if I use the chalk talk rather than PPT. But if some of you or the majority have already the measurements, we'll go also through your measurements, right? So it's up to you. Sound good? Good.